Here we have Harry standing at the top of the Grand Canyon, and he drops a ball off the edge of the Grand Canyon, and the ball falls to the ground. In the first part of this problem, we're asked how deep is the canyon where Harry dropped the rock. To solve this problem, I've already set up a motion diagram. I've first of all drawn a coordinate system in which the y direction is downwards, such that the position where the ball initially is corresponds to y equals 0. And at y equals 0, the velocity of the ball is 0. So these are our initial conditions for this problem. 7 seconds later, the ball hits the ground and it will have some position y. And to answer part A, we need to figure out what y is. The last part of this information is that the acceleration is known, and the acceleration is the acceleration due to gravity, which is 9.8 meters per second squared. And the direction of the acceleration is downwards, or in the positive y direction, which is why we have this positive sign in front of the 9.8. Okay, to solve this problem, it's just a straightforward application of one of our kinematics equations. We will use the equation y is equal to y naught plus the initial velocity in the y direction times t plus 1/2 times the acceleration in the y direction times t squared. Some of this is already known to us. We know this is 0. We know the initial velocity is 0 because Harry drops the ball. He doesn't throw it. And we can write out the equation as y equals 1/2 times 9.8 meters per second squared times time squared, and the time is the 7 seconds it takes for the ball to hit the ground. Now, this is straightforward. Plug these numbers in your calculator. You should get the canyon height where Harry is to be 240.1 meters. Now, what about part B? Harry has a brother who walked a little bit further along the canyon, and he drops a ball. He doesn't see the ball hit the ground, but he does hear the ball hit the ground 8 seconds later. And now we're asked to figure out how deep the canyon is where Barry dropped the rock. I've already set up the motion diagram for this. So here's Barry. Again, I'm choosing a coordinate system where the positive y direction is downwards, and at time equals 0 is where the ball is dropped with an initial velocity of 0 meters per second. So this ball falls, and at some time later, we don't know how long it takes. We're going to call that x. So at time equals x, the ball hits the ground, and it travels a distance of y, which we're asked to find. After it hits the ground, sound then travels upwards, and eventually Barry hears the ball hitting the ground, and we know something about the speed of the sound wave. The sound wave is traveling at 323 meters per second. So it takes this sound a little bit of time to reach the top of the canyon. So using this information, how do we figure out how deep the canyon is at this particular point? Well, let's break it into two parts. One is how far the ball falls and how far the wave travels. These two distances should be the same. So let's first write out what we know about the ball. So actually this problem is very much the same as part A. We can use the same equation. So the ball, in this case, falls a distance of y equals 1/2 times the acceleration, which is 9.8 meters per second squared, times time squared. Now in this case, time is x. X is the time it takes for the ball to hit the ground. It takes a little bit of time for the sound wave to go back up to the top of the canyon, and we're going to need to figure that out as well. So here is the distance traveled by the ball. Now sound has to travel the same distance. So sound is traveling with constant speed, so we can write out the distance traveled by the sound wave as the velocity of the sound wave times the time that it takes the sound wave to get to the top. And we know the total time of the ball falling and the sound wave moving is 8 seconds, and so we subtract x from 8 seconds, and that's the time it takes for the sound wave to reach the top of the canyon. Now these two y's should be the same, so we can equate them. So we have Vs times 8 minus x equaling 1/2 times 9.8 meters per second squared times x squared. Okay, now this is, if you notice, a quadratic in terms of x. We can rearrange this and substitute in the some of the numbers, and I'm going to let you verify this, but what you should find is that you get the equation x squared plus 65.9x minus 1.63 equaling 0. Now this is a quadratic. We can use the quadratic equation to solve this, and I've already done that, and you can verify this. I got the two time values being 0.024 seconds and negative 65.9 seconds. Obviously, we don't want the negative time value of 65. We need the time of 0.024 seconds. So this is the time it takes for the ball to hit the canyon floor. And now we can go ahead and figure out how deep the canyon is. So recall that y is equal to 1/2 times the acceleration in the y direction times the time x squared. And we just plug in our numbers, 1/2 times 9.8 meters per second squared times 8 minus 0.024 squared. And we get the following for the depth of the canyon. Y is equal to 311.7 meters.